Anyone hear me? So I'm going to be giving a very admittedly loose talk about what I did in the period before I got my first job over here. So I had a period where I was waiting for my work permission and in general didn't have that much to do. But I couldn't legally work, so I had to spend my time doing other things. So I ended up doing a fair bit of development in R. So a general overview of what we're talking about today is just a general how to approach open source software development. So in the case of R, it's about developing R packages and other tools. Then a little bit about my journey and what I learned from this short journey. This is all based on anecdotes, but I really hope that I'm not just a unicorn, and these experiences will be generalized to all of you if you wish to take part of this journey. Okay, so one of my main problems I had as a new developer was finding things I could do that was easy enough that I could code up myself that haven't already been developed by someone else. It was finding problems that wasn't done before. That was, for a long time, really, really hard. I would have a good idea and spend half an hour on it and then load it up and someone else had done it 4 years ago. So if you're in that early stage, I would advise just every time you have an idea, write it down and then do a lot of Googling to see if anyone else has been doing it before you. That being said, I will say that developing something that other people have already developed isn't useless, because you can learn a lot in the process of developing it itself. So really learning what a deep neural network is doing, coding one up from scratch, you really start to see everything that's happening. You might not never push it into production, but you have a deep understanding of what's going on underneath the hood. Okay, yes, this is what I talked about. It can be really, really tempting to just start working on a solution yourself, but for a lot of other times, people have been doing the same things you've been doing before, and you don't want to waste the time redeveloping what other people have been doing. This is an example of Nats that only spent 5 minutes developing before looking over to see what other people have done before. Ideally, you should do that first, but then early and often can stop you from redoing something other people have done. Okay. And there's also a case to be said about redoing something that other people have done in a slightly different way. So here's the classic example for SKCD, where a bunch of different packages, 14 different packages, all trying to do the same thing. And we decide, let's make an even better version. And then you have 15 different versions doing the exact same thing. Because it's very unlikely that the version you do is not encompass everything other people have done before. So it's a word of caution that if you want to do something other people have done before, it should be a really good idea. And most of the other implementations should be not bad, but it should be worth the step up. Okay. If you're a new developer, you can either find a project yourself you want to do, or look at existing projects and see what they haven't done yet. So what I find useful, especially for new people, is to go to the GitHub pages of the different R packages that you know and love, and look at the issues and try to find the different tags. So the little boxes after the name is what's called a GitHub tag, which is a way of categorizing the different issues. And some projects will have one called help wanted, which is basically saying this is something that we want to have done, but it's not in our immediate priority to develop ourselves, and we would like the community to pitch in if they would like. There's two main kinds. There's the stood first issue, which is something that stood for someone that hadn't really done something before. It's a fairly easy thing to do. And then just the general help wanted, that could be anything from something really easy to something so hard that the original authors don't know how to do it, but would like someone with the sufficient knowledge to help them implement that. And it's fairly easy. So if you go to, this is the tidier page, you can just go on the labels tab, scroll down, click the help wanted, and it will filter out all the issues. You only see the ones you want. And it's a very good way of just seeing what there is needed in the community. It's very important, which isn't said a lot, but it's a very good idea to ask before start working on your solution. So let's say we're doing bad, and I want to start updating, like the second one, updating a theme to remove panel.grid.major.x. It would be a good idea for me to go into the issue and just type, hey, it's good if I start working on this before actually starting working on it. Because someone else might have started working on it alongside you, and and depending on when you submit, like finish with your work, you would have wasted someone's time because multiple people have been working in parallel on the same solution. And depending on the issue, you also see that sometimes issues pop up in your repository saying, oh, we need to do this. And then in 2 hours later, solutions already made. So some developers use issues just as a mental checklist to remember to do everything. So they might put it up and just finish it off immediately just to have a paper trail of what to do.
Emil,
yes?
Who do you ask and where do you ask?
So let's just do it live. So I would go to the, so this is actually one of my packages, but let's say we're in here, we go to issues, and we, so like this one, add a step for weighted logs ours. So I have a thing, someone asked, can you do this? And I said I haven't had time for it yet. If you would like to do it, you would go in here and say, hello, do you mind if I take this? Send it, and then I'll respond back saying, hey, I'm not working on it, it's fine. Or if I'm already halfway through solution, I'll just say, hey, don't waste your time because it's almost done. And most people will be friendly if you send something along this way. I hope that answered. Perfect. You can also, in rare cases, email. If you can find people's emails, I would suggest always do issues first. Partly because it's like public and stays and things that's lost in an email. And also if you put it on an issue, everyone can see it, and other people also don't send concurrent emails and everything's hidden. It becomes quite messy. So my journey started with, so there's this wonderful package as part of the tidymodels called recipes. So this is a wonderful illustration by Alison Horst, who is a new resident artist in residence at our studio. So she's doing these wonderful illustrations of different packages and concepts. So the recipes package is a more streamlined and flexible way of doing pre-processing of data. And it's wonderfully stated, so you just specify variables, defining the different steps you want to do. So you can see in here, first we want to do some step imputation, continuous neighbor imputation, state all the data, censor it, and something more. And then everything is applied in a very uniform and stable way. So this is where I started. I saw this project and I liked it a lot. I saw this project, so now it says closed because I took the picture today, but basically there's this thing separate from issues called projects, which is just a longer list, a different kind of list of things you want to do that can encompass multiple issues. and I saw this that we want to do test preprocessing steps. So basically just steps that fall in line with the philosophy of the recipes package, but they deal with any kind of test preprocessing. And I did what any sensible person would do and shouted me, me, me. I can't find where I did it, but it ended up with this issue on the recipes package with Matt saying that I wanted to do it, and we started a discussion with other people that know things about test preprocessing to find out the right structure and format for this timing project. So the main problem in this framework is we have some unstructured tests, and it can be any kind of text, so short strings, long strings, varying number of characters, varying number of languages. Here just English, but it conceivably should work with other languages too. We put it through some kind of method algorithm and get out a bunch of numeric vectors. So basically just mapping from some kind of text feature space down to a numeric space. The reason why we're doing this is because most statistical models, machine learning models only accept numeric values as something you can optimize over. Do you have a question? It's not a problem. So this is basically the problem. So the problem is, what do we want to do up here? What different methods are we going to implement? The challenges in this thing was that the structure of text is very, you have a string, and that's basically it. It's hard to keep more information in it. And another very important thing is, in recipes, the order in which you do the steps are not pre-specified. So before we said, like we did imputation, stale, and centering, and you can do filtering. You can do in any order you want, and recipe is not going to stop you from doing that. This will make a difference because I need to get into a special, I need to find a special format to keep the text in to preserve as much information as I needed for that particular step. I made an early design choice to have high flexibility over the speed of the computation. Basically, a lot of times you should do tokenization, which is just splitting a string of characters into words or other units of text. You can do stemming, which is removing ends of words. You can remove not that commonly used words. You can do a lot of different things. And a lot of times in other implementations, a lot of these are bundled together. So you do tokenization, stemming, filtering. And there's no way to do tokenization, filtering, stemming, because it's all baked in. I wanted to allow you to do anything in any order you wanted, as long as the types match up. So this is the general flowchart I ended up with for the first version. So I ended up using list columns. So another constraint in recipes was that you basically stay in tuples the whole time, and every output from every step needed to be a tuple. So each test variable would then be converted into a list column of totals or other units. So basically you could do totalize into units. You can then remove stems or stop words. Filtering would then return back, or then later to numerics, you can do TDF, TF, text hashing to go to numerics. Later versions have also added word embeddings and other things. We have a pull request ready to do a bird word embedding soon, so that will basically just go directly from text to numerics. So there's a lot of freedom, and the ordering is, it has some constraints, but it's still, I would say, the most flexible solution you have out there. So this is, so going into steps, this is everything you need to include a step. So this is just the code for the stemming step, where I've taken out all documentation lines. And this is the code that is doing something. Everything else is scaffolding with a couple of small things. So I'm just creating a bunch of S3 generate and a main function has been used, and then it's just passing the arguments along to everything underneath. But the main calculations are done up in this bait step up here. So adding to this framework wasn't really hard because there's a lot of boilerplate. So my approach was finding a step that did roughly the same thing that I wanted to do, copy paste it over to my new file and just changing names where I needed to be. And if we take a look inside the highlighted code before, it's very simple once you get to know it. So let's run through it quickly. Yeah. So first we just extract out the column names. This is the columns that this step is working on. Then I'm using the do not remember null coalescing operator to basically say if I passed in a custom stemmer, it will take that. If it's null, it's going to take our default word stemming, and then we're just going to loop over the columns of our data, which is being passed in inside as new data. So I'm using my column name that I extracted, using it like subsetting the data, making sure I'm dropping it, and applying to native and putting everything back to the. It's a fairly standard thing, but a lot of this is needed. And if anything isn't the right format, everything else breaks down the line. So if I forget the as tipple in the end, something breaks. If I forget the text factor to text function, something breaks down the line. So as we see, there's a lot of intermediate steps doing all these weird things. Which means that when there's an error happening inside, it's happening pretty deep. So here I introduced an error inside my stemming step, and we see an error, test. And then I do trace that, and we see a pretty deep trace of 12 different levels. Also, what might not be obvious is that the first 7 of those are just happening because I piped something in. But basically after that, I call prep, which is a S3 generic that then calls at the prep recipe, which then calls the bait function, which is also a S3 generic, that then calls the bait.step underscore step. So we're in there. So we are already 4 levels deep inside a function where the data is hard to realize in there. So whenever I got a result I didn't know what to do, it's really hard to deduce what data was working with inside. So that's where I really like the browser function. So wait, anyone, raise of hands, know about the browser function and have used it? A couple of people, but not that many. So the browser function, basically you put it in your code, and when you run it, once it starts executing the browser function, it will pop out as an interactive session where you can then play with the objects in that local environment. So if you see right here, I typed in browser over here, I'm rebuilding the package, then I go over and run the example, and I stop inside the browser, and you can see that it's a little small, but these are the objects I have available to me right inside. And I can do live coding on the side on it, and basically see what objects do I have in that step. Once I use browser in this project, everything debugging became a lot easier because I didn't have to recreate the object types that I had 4 levels deep in some function in another package. But I don't have direct access to the bait or step functions. No, bait or prep functions, because they live in the recipe package. So it was a good way of stepping in to where I needed to be and then see what I have to work with. Okay. Another thing that happened a lot was a lot of follow-ups or post semi-regular issues where I tap in Matt's tool saying, this is what I've done so far, what do you think? What do you need to do better? And he would second we would chat back and forth, figuring out how far I was along in this whole project. I'm reiterating a little bit, but you don't want to reinvent the wheel. So this package is basically wrappers around 5 other packages that other people have already done before. So I'm not going to build a tokenizer because the tokenizer package is already built multiple of those. I'm not going to try to re-implement a term frequency calculator because other people have already built way more optimized versions than I did. When I started this project, I wasn't as clever, so I tried to implement my own version of a term frequency calculator, and it didn't run with more than a couple of hundred observations. And then I switched to the test to that, and I got like 1,000, 10,000 times increase in speed, because my method was just nowhere near as good as was already there. So instead of redoing, just using what other people have done before me. This project also includes one of my biggest did mistakes. I didn't break a lot of things, but I accidentally committed 13,500 files, totaling 2.5 million lines that I didn't need to commit, and it took a really long time to commit it because there's a lot of stuff, and I have no idea why, and I broke a lot of stuff, but I learned that when you add something to Github, you need to do it in the right order. And it also means that the contribution page for this project is totally useless, because one day has 2.5 million entries, and everything else is basically zero compared to. So I ruined some things with this. Basically, there's a lot of different things happening. I learned a lot. This was in a time when we also started having kittens. So I would wake up at 5, feed them and bathe them, and then work on this before my wife woke up, and we would go out and do stuff. So there's a lot of early mornings doing this. But I ended up, it went well, and happily I got a reward from it. I ended up joining my first organization, so I got part of the tidymodels organization. Doesn't mean as much as it sounds. It just means that I could move this package to the tidymodels package. So when you see on GitHub, it's not under my name, it's under the tidymodels organization. And that's basically everything it means, but it's nice to have, it doesn't say 0 organizations. I so far have 2 releases on CRAN. I got one little less than a year ago. I have another one came out. Next update, I'm going to focus on speed. So since I have the problem where everything needs to happen independently of everything else, I currently don't have a way of reusing information from earlier. So if I'm calculating counts of something, I can't use those later to filter it out. So I'm going to try to work on a way of adding attributes to my different list columns so I can use information from different places, but it's not really set in stone yet. We also have some development from outside doing the bird word embedding. So he created the bird R package, and it's also written the steps to hopefully integrate into this system. And lastly, I was lucky enough to be able to feature this package on the tidyverse.org website. So I was able to do a lot of shout out with the package, a bunch of retweet, and I have it up here. And that's everything I have. Any questions? Go ahead.
So you built a neural network that would train on unstructured text, and you were saying that you built the neural network from scratch?
No, so I didn't do that. So I'm wrapping other people's implementation of that to use in this framework, because it is, like the recipes framework is one of the newest and I would say best version to do preprocessing in a stable and safe way. So basically, so far I haven't implemented a lot of the methods. I'm just providing a wrapper around tool methods that other people have done, similar to how the Alan in React are. They're not rewriting the JavaScript, they're just making an R wrapper around what other people have done. So, yeah. Yes?
Wouldn't you really know that what you were trying to solve just wasn't available already in another package? And
So here I was lucky because they said we need someone to do it. So I assumed that they had looked hard enough to do this. And so I had the problem when I tried to do calculate test term frequencies. I tried doing that from scratch and found out it was horribly slow. And then I searched a little hard and found out, oh, someone with a very, very high focus on efficiency had already written this for me. So so the text to that, which I'm using for term frequency and a lot of other things, super, super fast, not the best interface. Like, it's really hard to make it shut up. Like, it really likes to output stuff, but it's really fast. So I'm just using what they did. But a lot of times it is, just look at other people done this before. If they have, just use it. At least in this case, because it's just wrapping other implementations.